Dear students, today I will discuss a very interesting question, and you can say a very basic question from refraction of light. And the question is on the definition of refraction of light. We know from the definition of refraction of light that when the light ray enters from one medium to other medium, it changes its path or it bends towards the normal or away from this normal. When light ray passes from rarer medium to denser medium, it bends towards its normal, and when it passes from denser medium to rarer medium, it will bend away from this normal. The question is why? Why when a light ray passes from rarer medium to denser medium, why it bends towards its normal or why it bends away from its normal? I have got many times this question from my students, and if you have the same confusion, then please see the video up to end. I am assuring you that you will get your definite answer. Okay, so let me discuss this thing first mathematically, and then I will discuss it physically also. So mathematically, using the help of Snell's law, and the basic thing that the refractive index of denser medium is greater than the refractive index of rarer medium. By using these two basic things, that is mu d is greater than mu r and Snell's law, we can easily prove that this I1 is greater than I2 here and I2 is greater than I1 is here, which is our task. And that is obvious because when the light ray bends towards its normal, then the incident angle I1 must be greater than I2. And when this light ray bends away from this normal, then the refracted angle I2 must be greater than I1. So if we can prove that I1 is greater than I2, then it will automatically prove that the light ray bent towards its normal. Similarly, here if we can prove that I2 is greater than I1, then it will automatically prove that the light ray will bend away from this normal. So first, let me discuss the thing mathematically by using Snell's law. Then I will discuss with you the same thing with a physical example or with a good analogy. Okay, that you can realize the thing why this light ray bends when it passes from one medium to another medium. That is why the refraction, the important phenomena refraction will occur. Why refraction is occurred in nature. When the light ray passes from rarer medium to denser medium or denser medium to rarer medium, why it will bend. I will discuss this thing physically also, but first let me analyze this thing mathematically. Okay, so initially I have taken that the refractive index of this rarer medium is mu r and the refractive index of denser medium is mu d. And if this is air, this rarer medium is air, then mu r will be equal to 1 for air. Okay, now if we use the Snell's law, then what will be the Snell's law? Mu r into sin I1 is equal to mu d into sin I2. Mu r into sin I1 is equal to mu d into sin I2. So sin I1 by sin I2 will be mu d divided by mu r, which will be greater than 1 because mu d is greater than mu r. If mu d is greater than mu r, then we can write over here that mu d by mu r is greater than 1. Similarly, here we will use mu r divided by mu d is less than 1. So if mu d by mu r is greater than 1, then sin I1 by sin I2 will also be greater than 1. So sin I1 will be greater than sin I2, and it implies that I1 is greater than I2, and which was our task and is completed. Similarly, in this case, if we use the Snell's law, then mu d into sin I1 is equal to mu r into sin I2. This is the general form of Snell's law, and I am advising the students to use this form. Then you do not have to be remember. Okay, so mu d into sin I1 is equal to mu r into sin I2 is the general form of Snell's law. Like mu d and the incident angle of this side, that is sin I1, so mu d into sin I1, mu r and the angle on this side, on that medium, that is mu r into sin I2. So mu d into sin I1 is equal to mu r into sin I2 again. So sin I1 by sin I2 is mu r by mu d, which is less than 1 now. So sin I1 is less than sin I2, so I1 is less than I2, which was our task and is completed. Now the big question is, how can we explain it physically other than mathematically? Okay, let me analyze this thing also. So now, with the help of this diagram and the basic definition of refractive index of light from electromagnetic theory, from Maxwell's equation, we can prove that the definition of refractive index, that is mu is equal to c by v, that is speed of light in vacuum divided by speed of light in medium. In which medium? The medium where this refractive index mu is defined. So now with this help of these two things, I can explain physically why the light ray bends when it enters from rarer medium to denser medium or denser medium to rarer medium. So from this definition we can see that mu is directly depends on v. So when the refractive index changes, then the velocity of light or the speed of light will also be changed. So here, if we take this mu generally, then it will be r mu d, that is refractive index of denser medium with respect to the rarer medium, that is mu d divided by mu r. And from this definition we can see that this mu d is nothing but c by vd and mu r is c by vr from this definition. So r mu d will be vr divided by vd. So you can write that mu d divided by mu r is equal to vr divided by vd. Mu d divided by mu r is equal to vr divided by vd. Now for denser medium, mu d is greater than mu r, and if mu d is greater than mu r, then vr is greater than vd. So the conclusion is that the velocity of light will decrease in denser medium. So when the light ray enters from rarer medium to denser medium, its velocity decreases. But the question is, why light does bend if velocity change? The big question is, why light does bend when velocity changes? And it can be well explained by using a simple analogy. Or you can say, I can use the light ray as the light wave, and these are the plane wave front. I have shown in this figure that these are a plane wave front. Other than, you can imagine this thing with a physical analogy, that this is a row of marching army. Okay, some army men are marching along this road, along this direction, and in rarer medium, the rarer medium you can compare it with a dry road, and the denser medium you can compare it with a sand road. So when the men are entering into this denser medium or this sand road, then their velocity will automatically decreases. When they enters from this rarer medium to denser medium, their velocity will decrease, because I am comparing this denser medium with the sand road and compare with the rarer medium with the tar road or a dry road. So as we are talking about the whole wave front, that is about the whole line, okay, total line A, B or C, D, and this total line is not incident or is not entering the second medium together. If you talk about these points, then these C points will enter this medium earlier and D point will enter this medium later on. And similarly for these points also, this point will first, this point will then, this point will then orderly it will reach this medium. So when this person enters into this sand road, its velocity will decrease. But this person who are already now in the dry road, its velocity will remain same. So for a particular time, say for time t, this man will cover this distance, but this man will cover more distance or larger distance than this. This DE will larger than this CE. Okay. So why it is so? Because velocity is decreases in the sand road. So this person C will cover small distance than the person D who will cover more distance, DF. Now these lines are parallel to each other because all the persons have same velocity. But when we have seen this CD and this EF line, then these are not parallel, because this D portion will move quickly and this C portion will move slowly now. But when all the persons or all the points on the wave fronts are enters into the second medium, that is the denser medium, then again it will move parallelly because their velocity will be same. Now if we join the midpoint of this light ray of this wave front, or you can say the analogy that the middle point of this line of marching army man, then you can see from this figure that this line will bend. And if you draw the normal over here, you can see that if this is I1 and this is I2, then I1 is greater than I2. So the light will bend towards its normal when it moves from rarer medium to denser medium. And the similar case will happen if we reverse the path of the light, it will retrace its same path. So when it moves from denser medium to rarer medium, if we change the sign, arrow sign, then the I1 will be greater than I2. So in this case, this is the incident angle and this is the refracted angle. So now it will bend away from this normal. So this is how we can explain physically why the light ray bends away from the normals or towards the normal, with the help of the analogy of this thing that is actually in physics is nothing but the wave front. Okay, thank you.